In BOE examination, number of numerical problems are being asked. Like if you see the questions, then such numerical problems of 5 marks, 7 marks, sometimes 10 marks, sometimes 15 marks are coming. And what we have seen during our training, that majority of the candidates, they are facing a lot of difficulties in solving these numerical questions, right? For example, if they see a question like this, calculate the size of the pipe, they go on thinking, okay, where to start, which angle to take, right? How to use the datas and the measurements which are given here. So what I have decided to create few concept lectures, basic physical measurement concept lectures, which is basically lacking in the candidates, and that is the reason why they are feeling most of the difficulties during solving the numerical problems. Hello and welcome to the YouTube channel of indiabolo.com. I am Anshuman Sen Sharma, and this particular video I am creating on the particular concept of volumetric flow and the specific volume, because these two physical measurements are being used time and again in various numerical questions, right? And I'm going to show you how to attack these numerical problems, right? What are the things to keep in mind, and small tips I'm going to give you, which is going to help you in understanding the concept and solving the problems at the same time. Okay, so starting with the volumetric flow. Volumetric flow is how much volume is passing through a particular pipe or duct or chimney, for that matter, any cylindrical thing, or it can be rectangular duct, right? So how much volume per unit time is passing through it. Now the volumetric flow calculation, one particular equation, that is Q is equal to V into A. Q is the volumetric flow in meter cube per second. V is the velocity in meter per second, and A is the area in meter square. Now this is the most important equation to remember, right? Now when I say equation, I can either memorize it or I can physically conceive it. Once you physically conceive it, the concept, if it is there, then it's not very difficult to remember the equations and putting it into practice. Okay, so let us see, if I am having a cylindrical pipe like this, through which steam or water or whatever fluid is flowing, right? The cross-sectional area of this pipe is, let us say, A meter square. Now how much volume is passing through it will depend on the velocity of that fluid to pass through this pipe or tube, right? If the velocity is V meter per second, let us assume, that means in 1 second V meter will be traveled by this fluid, so it is going to occupy V distance through the pipe. So how much volume would be there? So cross sectional into the distance travel is going to be the volumetric flow of this fluid through the pipe per second, right? That is the basic concept. So if I know the volumetric flow and the velocity, I can find out the area. If I can find out the area, I can find out the diameter, because diameter of a cylindrical pipe is pi d squared by 4. So from there I can find out the d, and vice versa. If I know the velocity and the diameter of the pipe, I can find out the volumetric area, volumetric flow, right? Like that, a number of such concepts are being used in various numerical problems. So let us put this particular concept into a small numerical example, which is something I am just creating for a basic understanding. So let us say calculate the pipe diameter through which 12,000 liters of water flows per minute with a maximum velocity of 40 meter per second. So here the velocity is given, the volumetric flow is given. Only problem is the volumetric flow is given in liter per minute. I need in meter cube per second. It is very important to have the proper units in mind, right? Because if I want to find out the diameter, I have to find out the area in meter square. So the volumetric flow has to be in meter cube per second if the velocity is given in meter per second. So I have to first change the volumetric flow from 12,000 liters per minute. Now 1,000 liters is 1 meter cube, I think all of us know. and 60 seconds in a minute. So I divide this by 1060. I get 0.20 meter cube per second volumetric flow. Now I know the velocity, which is 40 meter per second. So I am going to equate the area, because in this case area, if I need to find out, it will be volumetric flow by the velocity. So area will be pi d squared by 4 in case of a cylindrical cross section, because I want to find out the diameter, right? So I am equating this pi d squared by 4 is equal to q by v, 0.2 by 440, which is given, right? I get 0.005 meter square. Now once I know this area, I can find out the diameter by just solving the equation. So it will be 0.005 into 4 divided by pi, and since it is d squared, so square root of the whole thing, I am getting a diameter of 0.78 meter. In millimeter it comes to 78 millimeter. Now one point very important to note here. Do we have a 78 millimeter diameter pipe in the industry? Answer is no. We have got standard size. The nominal bore, the pipe diameter, pipe size is always expressed as nominal bore. So you have got 25 NB or 50 NB. You can have 40 NB, which is usually translated to 1.5 inch. You can have 80 NB. Yes, you can have 80 NB. That is 3-inch pipe, and you can have 100 NB. You also have 65 NB. Now, if we want to have a maximum velocity of 40 meter per second, so minimum diameter has to be 78 millimeter. So we have to choose 80 NB pipe, right? So your answer should come as the diameter of the pipe, the size of the pipe is 80 NB. Do not write 78 millimeter, because you are a boiler professional who is working, so you have to abide by the standard practices in the industry. Okay, now let us solve a question which I have earlier shown you, which has come in BOE papers, right? So this is the question which has come in Gujarat BOE 2023. As you can see, the marks given is 5 marks. So it's a 5 marks question. Very small question, very easy, because once you know this, that how to find out the size means diameter. The moment you see they are asking for diameter, what should you look for in the question? You should look for whether they have given you the volumetric flow and whether they have given you the velocity. Yes, they have given you the velocity 30 meter per second, but they have not given you the volumetric flow, right? They have given you 100 tons per hour, that is mass flow. Now when I have a mass flow, I can convert into volumetric flow, right? So what we do, first of all, we convert this 100 tons per hour mass flow to kg per second. So 100 tons is 100,000 kg, and 3600 we divide to get it into kg per second. So we are getting 27.78 kg per second as the mass flow. Now in order to convert into volume, now I need one more thing, that okay, volume is equal to mass by density, and 1 by density is specific volume. So I need another physical measurement concept, and that is specific volume. So what is specific volume? Is basically just inverse of the density, right? So specific volume unit will be naturally inverse of the density unit. Density unit is kg per meter cube. Specific volume will be meter cube per kg, right? Now in this case, I'm having a steam at 40 kg per centimeter square and 420 degrees centigrade. Now here I can find out the specific volume of the steam from the steam table, right? In one other lecture, if I can manage, I'm going to explain how the steam table can be used, how the specific volume can be calculated by using a steam table. However, at this point of time, let us say that the volumetric flow in this case will be the mass flow into the specific volume, and the specific volume from the steam table at 40 kg per centimeter square, you have to consider it as absolute, and 420 degrees centigrade superheated steam will come to 1.635 meter cube per kg. So the volumetric flow now we can calculate as the mass flow which you have calculated, 27.78 into 1.635, it comes to 45.42 meter cube per second, which actually is a very high volume, as you are going to find out. Okay, so now we have the volumetric flow, we have the velocity, we can find out the area and therefore the diameter. So now area will be 44.42 divided by 30, that comes to 1.51 meter square, and the diameter will come to 1.39 meter. Now 1.39 meter, almost 1.5 meter diameter steam pipe, which is absolutely impractical, right? However, in BOE questions sometimes we face this, that we get to find out. So what happens is, when you get such kind of a diameter, the first thing it comes to your mind that whether I have made a mistake or not, right? So you cross check that whether you have made a mistake or not. So once you have to do the calculations twice, and finally if it is coming to 1.39 meter, what can I do, right? You write that. Well, you can make a note, of course. It's looks very large. So the values which have been given in this question was not correct, right? Anyway, going ahead, these three questions I have shown in 2023 Gujarat BOE. This question, the one which you have solved just now, has come. Then in 2021, again 5 marks question. Again you see, find suitable size of pipe to carry 320 tons of steam per hour with a specific volume. Now here they have given the specific volume, so you need not refer the steam table. 0.22 meter cube per kg at approximately 40 meter per second velocity. So here they have again given the mass flow, 320 tons per hour mass flow. They have given the specific volume and they have given the velocity, right? So the first one we have calculated. The second one I think you can calculate, right? It is the same one, even easier because specific volume is given. So let us focus on the third question here. This has come in Chhattisgarh BOE 2016 with a 7 marks against it. It looks a little less marks because the question is actually very long. The question is on draft, chimney draft, and as I told you earlier also, that a number of states are giving you questions from draft, right? Now in this question they are asking you to find out the height and the diameter of the chimney. Now I told you, the moment diameter is coming, the values which you are going to look for in the question is whether they have given you the volumetric flow, whether they have given you the velocity, right? Because if volumetric flow and velocity is there in the question, then I can find out the diameter, right? So far as height of the chimney is concerned, that is a different thing altogether, right? So first of all, yes, they have given you the flow, but it is not the volumetric flow, it is the mass flow. If it is the mass flow, we have seen we need the specific volume or the density, whichever, because if I can calculate the density, it will be mass flow divided by density, right? Okay, now they have also asked the height of the chimney. Now height of the chimney, there are various equations which are basically requiring the draft concept, which I am going to deal later on if I get the time and opportunity, right? So from the draft concept, the height can be calculated from this equation. The draft in millimeter of water column, small h, is equal to height of the chimney in meter, capital H, into rho A minus rho G. Rho A is the density of air at the respective condition, pressure and temperature, and rho G is the density of flue gas through the chimney, again at their respective pressure and temperature. So if we can use this equation and if we can find out this rho A and rho G, which apparently in this question is not given, right? But again, this can be found out using another way, which I am going to show you. To find out this density or specific volume, you see here they have mentioned the gas constant of both air and flue gas. Now whenever you see the gas constant given in the question, it should strike your mind that you have to use the equation PV is equal to MRST. Now let me tell you, PV is equal to MRST, this equation, this characteristics gas equation, is used in various numerical problems in various manners, right? Again, in some of the video I am going to explain how the PV is equal to MRST is being used to solve various questions. But here, so far as this question is concerned, PV is equal to MRST, you can see that we can calculate M by V or V by M, right? So M by V will be, that is the density, is P by RST. Now if I know the pressure, the specific gas constant is given, the temperature, then I can find out the density. Inversely, the V by M is RST by P, right? So this is another way to calculate the specific volume. If they are given the gas constant, sometimes they might not give the gas constant of air, which you have to either calculate or you can assume, right? Certain assumptions are required and it is allowed in the BOE examination. So this way also you can calculate the density. Once you calculate the density, you put it in the draft equation, you can find out the height of the chimney. And once you know the specific volume, you can convert the mass flow into the volumetric flow. Now talking about the velocity, again the velocity is not given. But once you go through the draft concept, the chimney draft concept, you're going to find that yes, velocity can be calculated by this equation, root over of 2g into hg, where hg is the draft, is expressed as a height of the hot gas column in meter, right? The small h is the draft in mmWc, hg is the draft in meter of hot gas column. Again, this is a draft concept which I am going to discuss later on in one other occasion, and this hg can be calculated from the draft given as small h, that is draft in mmWc, by rho g. Now rho g, as you can calculate from PV is equal to MRST, you put this and you get your rho g. You can calculate the velocity, you can calculate the area of the chimney by volumetric flow by velocity, and from there you can find out the d by using pi by 4d square as area, right? So this is one just glimpse of one basic concept which is time and again will be used. Always remember this, that QV, volumetric flow, is equal to velocity into area. From here we can calculate a number of things, right? So with that I would say thank you and bye bye.